All right, if you're gearing up for the AWS Certified Solutions Architect exam, listen up. There is one service you absolutely, positively have to know inside and out, and that's AWS Lambda. Seriously, understanding Lambda isn't just about checking a box on the test, it's about getting the whole philosophy of modern cloud architecture, and that's exactly what we're going to do right now. We're going to break it down.
Okay, so here's our game plan. We're going to start with the big one. What even is AWS Lambda? Then we're going to pop the hood and see how it really works. After that, we'll get into the fun stuff, how you actually architect with it. We'll also break down the pricing so you know how you get billed. And finally, we'll talk optimization, squeezing every last drop of performance out of your functions. Let's do this. To really appreciate what Lambda brings to the table, you have to remember what life was like before. For decades, running any kind of application meant you had to think about servers all the time. Physical servers, virtual machines, it didn't matter. You were basically a systems administrator, whether you liked it or not. I mean, look at this. The old way was just a constant chore. You had to provision the servers, then you had to patch the operating systems, all those security updates. Then you had to figure out how to scale up when traffic hit, and, just as important, scale back down so you weren't burning cache. It was this endless, complicated dance. But serverless, it just flips the whole script. You literally just upload your code and it runs when you need it. That's it. The end.
Now, let's be real for a second. The name serverless is kind of tricky. It doesn't mean the servers just magically disappeared. Of course they're still there. But here's the absolute key. You don't see them. You don't manage them. AWS handles all of that. The hardware, the OS, the patching, the scaling, all of it. So you can finally just focus on writing code that does cool stuff.
And that, my friends, is AWS Lambda. It is the heart and soul of serverless on AWS. It's the compute service that lets you run your code as these little independent functions, and they only execute in response to some kind of trigger or event. It can scale from nothing to thousands of requests a second, and you don't have to do a single thing to make that happen. Okay, so we get the basic idea of what it does, but for that exam, you gotta know how it does it. What's really happening under the hood when a Lambda function gets triggered? Let's peel back the curtain.
So everything in the Lambda universe starts with an event. This is a super common pattern. You've got a user request that comes in and hits, say, an application load balancer. Now, that ALB doesn't just forward the request to an EC2 instance you're running. No. It turns that request into a little package of data, an event, and shoots it over to the Lambda service. That event is the signal. It's the go button that tells Lambda to wake up and run your code. Now this is a detail you'll want to remember for the exam. Your code isn't just running in some generic container. It's running inside something called a Firecracker MicroVM. You can think of it like a super tiny, super fast, ultra-secure little fortress for your code. The big takeaway for an architect is the incredible security and isolation this gives you. It means your code is totally walled off from anybody else's code that might be running on that same physical machine.
So let's just quickly walk through the lifecycle. Step 1, an event happens. Maybe a file gets uploaded to S3, maybe an API call comes in. That's the trigger. Step 2, Lambda finds or creates one of those secure Firecracker environments. Step 3, your code's handler function gets executed, and it gets all the data from that event. And finally, step 4, once it's done, that environment might get frozen and reused for the next request, which is way faster, or it'll just be terminated.
Okay, knowing the mechanics is great. But as a solutions architect, your job is to design things. And that means you have to know the rules of the game. You need to understand Lambda's limitations, its security model, and exactly what you are responsible for. And this slide right here is one of the most important concepts for the exam, period. The shared responsibility model. With Lambda, AWS takes on a massive amount of the work. They're responsible for the physical servers, the operating system, the runtime, all of it. But your job is still critical. You are responsible for your code and its dependencies, and, most importantly, the IAM configuration that dictates what your function is allowed to do. And here's the thing, Lambda is not a magical box with unlimited power. It has hard limits, quotas, and these directly shape your architecture. See that timeout? 15 minutes, that's it. If you have a job that takes longer, you need a different tool for the job, like AWS step functions. And look at memory. That's your one and only dial to control CPU power. Need more CPU? You have to give it more memory. These aren't just numbers to memorize, they're the guardrails for your design. And when we talk about security, this right here is the golden rule. Every single Lambda function needs an IAM rule to run. And that role should only have the absolute bare minimum permissions it needs to do its job. If your function just needs to read from a single S3 bucket, then for heaven's sake, don't give it permission to read from all of them. This is the principle of least privilege, and you'll see it pop up all over the exam.
All right, now for the question that's always on everyone's mind. How much is this going to cost me? So let's demystify Lambda's pricing model, which honestly is one of its best features. It's actually incredibly simple. You pay for two and only two things. First, the total number of times your function is invoked. That's the request charge. Second, you pay for how long your code runs. They measure this in something called gigabyte seconds. It sounds a little weird, but it's just the memory you allocated multiplied by the time it ran, and it's billed down to the millisecond. You truly only pay for what you use.
And you know what? The deal gets even sweeter because there's a perpetual free tier. Every month, your AWS account gets 1 million free requests for free.
And on top of that, you also get 400,000 gigabyte seconds of compute time for free. Put those two together, and you can run a pretty serious workload without ever paying a single penny. It's totally possible for your bill to be zero. Now, as an architect, you've also got a key decision to make. By default, Lambda is on demand. It scales up and down as needed. This is awesome for unpredictable traffic, but it can lead to what's called a cold start. For apps where every millisecond counts, you can choose to pay for provisioned concurrency. This basically keeps your functions warm and ready to go instantly. It's a classic architectural trade-off. You're balancing cost against performance. And speaking of performance, that brings us to our final section. Because even with a service that scales for you, there are always tricks to make things faster. So let's talk about that infamous performance challenge in the world of serverless. So what is this cold start thing that people are always talking about? A cold start is really just the delay you experience on the very first request to a new instance of your function. It's the time it takes Lambda to spin up that secure environment and load in your code. It can add a little bit of latency, maybe a few hundred milliseconds, sometimes a couple of seconds. But here's the key. Every request after that first one goes to a warm instance, and it's lightning fast. And, one of the easiest ways to improve your performance is to think about your runtime. Your choice of programming language actually matters a lot. Research has shown that different runtimes have different performance profiles. For a lot of general-purpose functions, languages like Python tend to offer a fantastic blend of speed and cost-effectiveness. It's a simple choice that can make a real difference. Okay, let's finish up with a little brain teaser straight out of an exam scenario. We know a single Lambda function dies after 15 minutes. So what do you do if you have a job that takes longer, like processing a massive video file? How would you solve that? Which AWS service is designed specifically to coordinate and orchestrate multiple Lambda functions to get a big job done? I'll let you think on that one.